Oh, there's one of my old favorites from back in the day. That might be a little too old for most of you. Maybe your parents picked that one up a little quicker, but certainly a good old song from Lynyrd Skynyrd, and I encourage you to try to look that up and find the title of that song for me tomorrow in class. But welcome to another edition of our Flipped Classroom. Our title today is Fractional Exponents. And as we get ready to rock and roll here today, we have just one very important rule to focus on, and that rule says that if we have the nth root of x raised to the m power, that is equivalent to x raised to the m divided by n power. And that's our one rule today. We've got to learn that rule forwards and backwards. I'm going to go ahead and take what used to be my equal sign and turn it into kind of a double arrow, signifying that this is a two-way street. We're going to be expected to convert from radical form into fractional exponent form, and then also vice versa, starting with the fractional exponent and converting back to the radical form. So we're going to continue to practice this. A couple of things here. When you're looking at the expression in radical, or as a fractional exponent, it is the root that is on the bottom. Okay, the root is in the denominator. If you can just continue to remind yourself of that, you'll have a lot better odds with this lesson today. You'll notice our subtitle today, I called it the groundhog rule, and I know I've had some awkward, ridiculous rules at some point this year, and this might be the king of all of the awkward, ridiculous ones. But here's how my rule goes. It says if I start in fractional form and I want to convert it into radical form, here's what's going to happen. I'm going to switch pen colors here really quick. What used to be the bottom number there is going to burrow a hole through the ground and pop up on the other side, much like a groundhog digs holes in the ground. And that nth is going to pop up on the other side right there. And then we just have our x to the m power. So it's the n that does the traveling. You'll notice the m's never moving, the m's staying where you put. It's the n that does the traveling. And so a lot of times I'm going to refer to it as the groundhog rule, and hopefully it's sometimes the silliest rules stick with us the longest. Let's get ready to go try a couple of examples. Okay, our first series of examples, the directions ask us to rewrite the expression with a fractional exponent. You notice example number 1, 4th root of x to the 3rd power. This is in radical form right now. We're going to convert it using the groundhog rule. Like we said, the 4 is going to do the traveling, the 3 stays put. So I'm going to rewrite that as x raised to the 3/4 power. And just to emphasize there a little bit, the 4 going underground, popping up as the denominator on the other side, hence our groundhog rule. Let's go ahead. We're going to fly through a couple of examples here. What if I gave you the cubed root of just plain old x? Now you'll notice it does not appear right now that there's an exponent on the x, but there is an invisible 1 right there. And I would encourage you to get in the habit of writing that in there just to remind yourself that there is indeed an exponent there. So as I go to rewrite that, I'm going to rewrite it as x raised to the 1/3 power. Again, the 3 in that case does the traveling. Our third example wants us to take the square root of x and rewrite that as a fractional exponent. Now, you'll notice in this problem, there are 2 invisible numbers. The first one is the 2 that sits right there as the index, and then the other invisible number is the 1 on the exponent. So as the 2 does the traveling, we could rewrite that as x raised to the 1/2 power. That one right there is a very, very popular example, and I hope you feel comfortable converting from radical form into the fractional exponent. And let's see, number 4 says, let's take the cubed root of x to the 8th power. We'll rewrite that as x raised to the, and here's a good chance to hit the pause button and try to predict the answer. Hopefully you went with 8/3. X raised to the 8/3. One more really quick I'm going to squeeze in here on the other side. What if I have the quantity, start over. I want the cubed root of the entire quantity 2x raised to the 2nd. So as we go to rewrite this, we're going to make sure that we continue to have parentheses around the 2x. We're going to say it's the entire quantity 2x that's being raised to the 2/3 power. Our next series of questions has a set of directions that asks us to rewrite the expression in terms of a radical. And as we go through these, I want you to practice pronouncing these correctly, whether it's the cubed root or the fifth root or the fourth root, whatever the root might be. I want to just, history has shown us that we're not really comfortable at pronouncing all of these different roots. But anyway, with a little bit of practice, we'll be real good at it. So example number 6 in our notebook asks us to take x to the 4/5 power, and we're going to rewrite it in terms of radical. Again, in this case, the denominator, which happens to be the 5, is going to do the traveling. The denominator is the number that's going to become my root. So we could say the 5th root of x raised to the 4th power. Now, a little while later in the lesson, we're going to show you how to do the 5th root on the calculator, and we're going to get real fancy and use some new features on our calculator. The next example, number 7, let's take x raised to the negative, yes, we said negative, 1/6 power. So now we're going to incorporate one of the rules we learned on our previous lesson. The first thing I want to do, we're going to make this kind of a two-step problem. I'm going to rewrite it so that my base x is in the denominator. Once I move that x to the bottom, now my exponent's going to change signs and become a positive 1/6. Now we can use our groundhog rule. We're going to say 1 over the denominator, being the 6, is going to do the traveling and become my root. So I'm going to say the 6th root of x raised to the 1st power, and writing the 1 as the power is an unnecessary move, but it wouldn't be wrong if you put it there. Example number 8. Let's take 4x to the 2/3. Now the biggest question here is ask yourself, who actually is being raised to the 2/3? In this case, because there's no parentheses that are visible, we know for a fact that only the x is being raised to the 2/3. The 4 is not included in that power, so we could almost say that there's an invisible set of parentheses right here. Only the x is being raised to the 2/3 power. So as we go to rewrite that in radical form, we're going to leave the 4 on the outside. And then we're going to say to ourselves that the 3 does the traveling. We got the cubed root of x squared. Very important that the 4 is on the outside of that radical. Now let's compare that to the next example that's going to look very similar. We have parentheses, the quantity 4x raised to the 2/3. Here's what it would look like if I wanted the entire quantity raised to the 2/3 power. I would have to use parentheses, and in this case, as I rewrite it, we're going to say the cubed root of the quantity 4x squared. And again, those parentheses are very, very important. At that stage of the problem, they have to be there. If you want to go a little further, you can, and we could say the cubed root of 16x squared. And that would also be equivalent. We're going to do 3 more examples with the same set of directions. Let's take 6x to the 1/2 power and rewrite that in radical form. Another good chance to hit the pause button and try to rewrite this one yourself and then come back and see if you got the same answer. What I'd like to emphasize here is that only x is being raised to the 1/2 power. They will not give those parentheses to you. That's something that we just have to know where that invisible set of parentheses is. So as we rewrite this, we're going to leave the 6 on the outside, and then the denominator, the 2, does the traveling. We've got the square root of x raised to the 1st power. Again, the 2 as the index is an invisible 2, and the 1 as the exponent is an invisible 1. Those are numbers we usually don't write. If you did write them, it wouldn't be wrong, but we just customarily don't write them. Example number 11 says, let's take the quantity x squared minus 9 and raise that to the negative 2/3 power. Again, we have the first thing that we want to address is the negative exponent. So all I'm going to do is I'm going to take the quantity x squared minus 9, and technically right now it's in its numerator. I'm going to move the quantity x squared minus 9 and put it in the denominator. Once I make that move, my exponent changes signs, and now it is a positive 2/3. Last move here is we're going to use our groundhog rule. We're going to say the cubed root of the entire quantity x squared minus 9 being squared. And that's as far as I can go, and that right there would be my final answer, 1 divided by the cubed root of the quantity x squared minus 9, all being squared. Our last example in this section is another similar example. Let's take the quantity 2x plus 3, and let's raise it to the negative 1/4 power. Again, take a moment here to hit the pause button and try to rewrite this one in following the previous example that we just completed. Okay, hopefully your first move was to rewrite it as 1 divided by the quantity 2x plus 3. Once we move the base down to the denominator, our exponent changes signs, and it's now positive 1/4 power. And my last move, the groundhog rule says it's the 4th root of the quantity 2x plus 3. Now you notice I don't have to keep the parentheses around the 2x plus 3 this time because it was simply being raised to the first power only. That made the parentheses unnecessary at this stage of the game. Okay, we're going to move on to our next section. We're actually going to practice evaluating a few of these. We're going to practice evaluating a few of these expressions without using our calculator first, and then like I said earlier, we are going to eventually use our calculator and learn a few new buttons. I think we're very comfortable with our perfect squares. I just want to refresh our memory with perfect cubes. And our perfect cubes look like this. The first perfect cube is 1, and then 8. 8's a perfect cube because of 2 times 2 times 2, and then 27. Let's see, 4 cubed is 64, 5 cubed is 125, and that's probably the biggest one we're going to try to do without the calculator tonight. Okay, so we'll be using those shortly before too long. Our first expression says we want to do 4 raised to the 3/2 power in our head without a calculator. So the exponent is 3 divided by 2 if you can't read that. I want to rewrite that in radical form. I'm going to say the square root of 4 to the 3rd power. And throughout your entire math career, we've always stressed how the order is important. The order in which you do things is very, very important. Here's one of the rare times where I'm actually going to tell you that the order does not matter. It is your choice. If you want to take the square root of 4 first, go ahead and do that. If you want to raise 4 to the 3rd power first, you can go ahead and do that. The order does not matter, but I do want to suggest, I think there are more efficient ways, there's a smarter way to go about this one. And I'm going to encourage you to take the square root of 4 first, then we'll take that result and raise it to the 3rd power. So the square root of 4 gives me a 2, and then we're going to raise it to the 3rd power, and my final answer would be 8. So therefore, 4 raised to the 3/2 power is equal to 8, and we just evaluated that without a calculator, and I think we made it look fairly easy. Number 2, how about let's try 4 raised to the negative 3/2 power. Very similar as to the last example. The only thing that's going to change is my very first move. Anytime you see a negative exponent, you want to address that head on right away. We're going to rewrite it as 1 over 4 to the 3/2. Then I can use my groundhog rule and rewrite it as 1 over the square root of 4 cubed. And then, as we saw in the last example, I'm going to do the square root of 4 first. And then we got to cube it, and my final answer is 1 over 8. Here's a note. I can't stress this enough. Just when your exponent's negative, it doesn't mean that you're going to get a negative answer. It actually means that you're probably going to get a fractional answer. And notice our answer certainly was not negative. Let's try 25 raised to the negative 3/2 power. First move, we're going to rewrite it as 1 over 25. Now the exponent is positive 3/2. Our groundhog rule says we can rewrite that as the square root of 25 raised to the 3rd power. Let's see, that's 1 over 5 cubed. Notice just like the last example, I evaluated the square root of 25 first, and then last but not least, our final answer is 1 divided by 125, and we just barely fit that on the screen. Okay, let's go get a couple. Our fourth example in this section wants us to take 8 and raise it to the 2/3. As we rewrite this, I'm going to say the cubed root of 8 squared. We could do 8 squared first and then do the cubed root, but I'm going to encourage you to do the opposite. I want to do the cubed root of 8 first. 8 again is a perfect cube, therefore the cubed root of 8 is just a 2. And then we'll go ahead and square that result, and my final answer is 4. So just to recap there, we evaluated the cubed root, where's that? Cubed root of 8 first, and then we squared the result of that expression. Alright, our last one for this section wants us to do 64 to the negative 2/3 plus 64 to the negative 1/2. 64 is one of our favorite numbers to work with because the reason it's unique is that 64 happens to be a perfect square and a perfect cube. Of course, the square root of 64 is 8, and then the cubed root of 64 is 4, and that's something we're going to have to do our best to try to keep straight in our heads. So I'm going to work vertically down the page. My first term, I'm going to rewrite it as 1 over 64, now raised to the positive 2/3, plus, in the second term, I'll do likewise. I'll rewrite it as 1 over 64 to the positive 1/2 power. Just like we mentioned earlier, we want to address those negative exponents head-on right at the beginning. Now I can rewrite it using the groundhog rule. I've got 1 divided by the cubed root of 64 squared plus 1 divided by the square root of 64 raised to the first power. If I go ahead and I evaluate the cubed root part first, the cubed root of 64 is going to give me a 4. And then once I square that, I'll get 16. And then this last one, the second term is a little easier. Square root of 64 is simply 8. And now I need to get common denominators. 1 divided by 8 is equivalent to 2 divided by 16. Now I got my common denominators, I'll add them, and my final answer is 3/16. That sounds like a wrench my dad used to make me go find in the toolbox. Our last section for the night has to do with evaluating expressions using our calculator. Now what I want you to do is I want you to get out your calculator, and on the left-hand column, the third button from the top says Math, and I want you to hit that button and take yourself to the Math menu. Now recently we've started using choice number 4 recently. My picture is very blurry, but you can see it on your screen. Choice number 4 is a special button for the cubed root. What we're going to do is we're going to graduate and we're going to start to use option number 5, which on your calculator says the xth root. That's a very hard one to pronounce. That's the xth root. And what that does is it has the potential to take any root that your heart desires. If you want to take the 63rd root of some crazy number, you're more than welcome to do so. We're not going to be quite that exciting. We're going to stick to like 4th roots and 5th roots and so forth. Certainly not as exciting as trying to take the 172nd root of something. But nonetheless, we'll go ahead. We'll try a couple of examples. And I want you to follow along and practice on your calculator. Get in the habit of using the correct button sequence and so forth. So the first one we want to try to use with our calculator is the 5th root of 32. Easy, Bailey. Really? All right. So the first thing we're going to do on our calculator is, before we actually hit that math button, let's start with a fresh, clean screen. Okay? And you actually have to type in the number 5 first. Then we're going to hit the math button. Once you're there, we're going to choose option number 5. You can just hit 5 and you're automatically good to go. And you'll go back to your calculator screen and then type in the 32 and hit enter then. Hopefully the calculator should spit out a very clean whole number, 2. Our answer should be 2. And I'm going to try to pull up what my calculator screen looked like. Okay, here it is. Here's what my screen looked like. Just remember, before you go to the math menu, type in that 5 first, and then go to the math menu, get option number 5, type in your 32, and hit enter. Now, my calculator is the updated version, and so what it did is it got real fancy, and it actually rewrote the 5 so that it looks like a nice index. And then, of course, we got the nice number 2. So what we actually just learned is, we've never talked about perfect 5th powers before, but we just learned that 32 is actually a perfect 5th power. And I think that's easy to convince yourself. Try to turn this one around. You'll notice 2 raised to the 5th power, also known as 2 times 2 times 2 times 2 times 2. Go ahead, and if you try to work that out, hopefully you'll get 32 as an answer. Let's do two more. Okay, they want us to take the fourth root of 36. All we're going to do is we're going to start with a fresh, clean screen on our calculator. We're going to type in the 4 first. Then we're going to go to the math menu. We're going to choose option number 5 from that menu. I'm going to put little arrows in between these steps. Hopefully that'll clarify. After you choose option number 5, we can type in our 36, hit enter, and see what you get. Hopefully your screen looks something like this. We had the fourth root of 36. I hit enter. I got a very obnoxious irrational number this time as opposed to the clean whole rational number I got earlier. We're just going to have to read the question carefully on a test and see how many decimal places they want. If they want me to round to the nearest hundredth, implies that we're going to need 2 decimal places. So for this particular example, I would say 2.45. You notice that 9 sitting in the third spot, that causes me to round up to a 5. There's our nearest hundredth right there. Our very last example of the night, we're asking for the fifth root of 125. I'm going to encourage you to go ahead, type that into your calculator all on your own, and round your answer to the nearest hundredth, and then come back and check and see if you got the right answer. I ended up with 2.626527804. If we round to the nearest hundredth, I ended up with 2.63, and that is known as the fifth root of 125. Well, ladies and gentlemen, that wraps it up for tonight's lesson on fractional exponents. Hope you enjoyed your day off on Tuesday, and now it's time to get back in the groove and try to rally for our big test on Friday. This will be our second to last test of the quarter, and hopefully we can put up a high enough score to knock out some previous tests. Good luck, and we'll talk to you tomorrow.